Today's topic is laws of chemical combinations. Chemical combination, we can consider it as reactions. So what are the rules during the reactions? That is our discussion today. So there are five laws of chemical combination. But here we will discuss only four of them. And these laws of chemical combination developed about 250 years back. At that time, there were no idea about elements, atoms. So the atoms or subatomic particles that were not discovered at that time. So in such a situation, there is no facility to find out or analyze, such as spectroscopic analysis were not known at that time. So in such a condition, they proposed several laws related to the combination of different substances. That means reaction between different substances. The first important law is law of conservation of mass. Law of conservation of mass. The statement of this law. The law states that matter can neither be created nor destroyed. Matter can neither be created nor destroyed. It is not possible to create matter and it is not possible to destroy matter. That is the law. It is proposed by Anthony Lavoisier in 1789. Lavoisier proposed this law based on certain observations, not based on experiments or other things, based on certain observations. Or this law can be stated as in a chemical reaction or in a chemical combination, total mass of reactants equal to total mass of product. Example, 2H2 plus O2 gives 2H2O. Now, from this equation, we know 4 gram hydrogen combines with 32 gram oxygen and forms 36 grams of water. So 32 plus 4 equal to 36. The mass of water formed also equal to 36. Total mass of reactants equal to total mass of product. Here, no matter created, no matter destroyed. If there is any creation, the total mass of the product should be greater than 36. If there is any destruction of matter, the total mass of product should be less than 36. But we can see the total mass of reactants and total mass of products are equal. So what is the statement of law of conservation of mass? It states that matter can neither be created nor destroyed. Now the next law, law of definite proportion or law of constant proportion or law of definite composition. The law of definite proportion, law of definite composition or law of constant composition. This law proposed by Joseph Proust, and it is about the composition of different compounds. Composition of compounds. For example, if we take water from well, if we collect rainwater, or if we prepare water in the laboratory by the combination of hydrogen and oxygen or by the burning of hydrogen in oxygen, whatever may be the source of water, we know the constituent elements are hydrogen and oxygen. There is no change in the constituent elements. hydrogen and oxygen. And they are combining in a particular ratio. 2 gram hydrogen is combining with 16 gram oxygen. That means 1:8 ratio. There is a mass ratio 1:8. If you take water from well, the ratio will be 1:8. Ratio of hydrogen to oxygen will be 1:8. If you collect it from rainwater, the ratio will be 1:8. And if you prepare it in the laboratory, then also the ratio will be 1:8. That is law of definite proportion. So what is the statement? This law states that same compounds always contain same elements combined together in the same fixed proportion by mass. Same compounds always contain, same compounds, water, always contain same elements, hydrogen and oxygen, combined in the same fixed proportion by mass, 1:8. So what is the statement of the law? Same compounds always contain same elements combined together in the same fixed proportion by mass. This law is very simple. And I think it is very clear to you. If we collect any substance from anywhere, it will have some constituent elements in it. And the ratio of the elements in that compound will be the same if we collect it from anywhere else. That is law of definite proportion, a very simple law. Now the next one is law of multiple proportion, proposed by John Dalton, a great scientist. And it arises if there is a chance to form more than one compound from two elements. If two elements can combine to give more than one compound, this law can be applied. So we can state this law in this way. If two elements can combine to form more than one compound, if two elements can combine to form more than one compound, then the different masses of one of the element combining with fixed mass of the other element, different masses of one of the element combining with the fixed mass of the other element bear a simple ratio. That means simple ratio between different masses of an element, different masses. If it is forming two compounds, the masses of the one of the element will be different. Here an example is given, carbon dioxide and carbon monoxide. When carbon and oxygen combines, we will get two compounds, carbon monoxide and carbon dioxide. Carbon monoxide, what is the molecular formula? CO. Carbon dioxide, what is the molecular formula? CO2. So carbon monoxide and carbon dioxide, two compounds will form. When carbon and oxygen combine, it can form more than one compound, that is carbon monoxide and carbon dioxide. In such cases, different masses of one of the element, here we can take oxygen, different masses of oxygen, which are the different mass of oxygen. In carbon monoxide, only one oxygen, that means 18 grams of oxygen. In carbon dioxide, two oxygen, that means 36 grams of oxygen. So different masses of oxygen means 18 gram and 36 gram. Different masses of one element, 36 gram, 18 gram and 36 gram of oxygen. That combined with a fixed mass of the other element. Here is the other element, carbon. The two cases only one carbon, that means 12 gram carbon. And in the ratio of small whole numbers, the different masses are in the ratio of small whole numbers. So 18 and 16 and 32. What is the ratio? 1 is to 2. That is a simple ratio. So oxygen, in carbon monoxide, oxygen has only 16 gram mass. But in carbon dioxide, oxygen has 16 plus 16, 32 gram. 32 gram mass. So the masses of carbon are same, 12 gram. In the two cases, it is 12 gram. But masses of oxygen are different. In the first case, carbon monoxide, it is 16. And in the case of carbon dioxide, it is 32. So there exists a simple ratio between the masses of oxygen that combining with the fixed mass of carbon, which are the different mass of oxygen 16 and 32. So what is the ratio of 16 and 32? 1 is to 2. That is law of multiple proportion. Here always there is a chance to write it in a wrong sense. Here the ratio is not between different mass and fixed mass. The ratio between two different masses. That is given here. Don't mistake it. So I think already I told you as the mass of oxygen 18 and water was 36. That is not correct. Mass of oxygen 16 gram and O2 oxygen molecule 32 gram. 32 gram. Okay, I think it is clear to you. In these first three laws, we discussed the mass ratio. We consider the mass of different elements present. Now we are going to the fourth one. There we will consider the volumes of the reactants and products. The fourth law is Gay-Lussac's law of combining gaseous volumes. Gay-Lussac's law of combining gaseous volumes. It is proposed by Gay-Lussac as it is given in the law, Gay-Lussac's law. And it states that when gaseous reactants combine to form gaseous products, they do so in a simple ratio by volume. One condition is that if all the gases are at the same temperature and pressure. What is the gaseous reaction? Gaseous reactants combines to give gaseous product. That is gaseous reaction. So in gaseous reaction, this law is applicable only in the case of gaseous reactions. In gaseous reactions, the volumes of reactants and products are existing in a simple ratio. That is Gay-Lussac's law. When gaseous reactants combine to form gaseous products, they do so in a simple ratio by volume. Here, ratio by volume, not mass. Simple ratio by volume. If all the gases are at the same temperature and pressure, there should not be any change in the temperature of the reactants and products. That is a condition. If there is no change in temperature and pressure, means at the same temperature and pressure condition, in a gaseous reaction, there exists a simple ratio between the volumes of reactants and products. For example, we can see the reaction of hydrogen and nitrogen to form ammonia. Here hydrogen and nitrogen are reactants and ammonia is the product. But all hydrogen, nitrogen, ammonia are in gaseous state. And here what is the volume? What is the ratio of volume? 3 volumes of hydrogen combining with the 1 volume of nitrogen to give 2 volumes of NH3. So what is the ratio? 3:1:2. It is Gay-Lussac's law of combining gaseous volumes. I think it is enough for today. You have to study and by heart these laws very well. Then only we can solve numerical problems based on these laws. Okay, study it very well.